Okay, I think we're about ready to go. Checking 1, 2, and 3. Hopefully this is all working, and we've got some audio, we've got some video, and not seeing any feedback, so I'm just going to assume everything's working, and we'll just start into today's stream. So, what are we doing today? So we threw a poll out, well, I guess that would be 2 weeks ago now, asking, what do you guys want to see a stream on? There's a couple options. I think there was what's new in 2021. There was demo a 3D toolpath. There was program a basic Mastercam part start to finish. And there was an option for working through a program in Macro B, custom Macro B. And that one seemed to have won, so that's what we're going to do today. I'm going to work through a program. Hopefully we can get through it. Again, we're going to try and do this for about an hour. Can we get all this inside of an hour? It's going to be close, but we'll see what we can do. Hopefully we can get through most of it. So with that, the message that went out with the stream as well, there was, we were talking about we're going to program Macro B, and we also said there was a bit of an announcement that we had to put out. So that we'll save for a little bit later, I guess, maybe about halfway through. We'll talk about the big news, and yeah, once we had enough of Macro B for a bit, we'll talk about the big news, and then we'll continue on with the stream. So let's hop into this now. Get started, or else we'll never get finished. So up on screen, I've got an editor. So this kind of ties in with last week's video as well. We were talking about editors inside of Mastercam, and why you would use one versus the other. And we mentioned that with Simco, you can backplot your programs. So not only your Mastercam programs, but also programs that you write, which is extremely helpful because Simco can also simulate Macro B. So with this, let's just hop into a new file here. I'm going to be bouncing around between a couple different softwares today as well. So this is Simco, like I mentioned, it edits and backplots gcode as well as macro gcode. There's another software as well called NCPlot. I use this one quite a bit as well when we're doing macro programming. The difference here is NCPlot has a variable display list. So basically when you're programming with macros and you're creating variables, you can see those variables in real time in NCPlot, which you cannot in Simco. So that's why I like to use Simco or NCPlot. But the interface in Simco I just like a little bit better because it's a little cleaner, and it does have solid verify as well. So I'll be bouncing back and forth between those two. And then also when I've got some ideas to talk about, I'll probably hop into SmoothDraw here and just do some sketching about planning this macro variable or macro program that we want to do. And then if needed, if we need some accurate drawing, I'll hop into Mastercam and we can sketch up some accurate drawings and do some dimensions and stuff like that. So starting into our macro program here, we do have 2 videos already out on the blog and on YouTube talking about macros in a brief introduction. The first one is a really basic cutting a square and then sticking in variables to adjust the size of that square. Video 2 took it one step further, and it talked about calling up a macro and passing variables to it. And we did a drilling program with that. So with this one, again, we're not getting into much theory as to what the variables actually are and how they work and that, but I think we'll take this one step further. And with facing, what we'll need to do is not only create variables to adjust the size of the block we want to shape, but as we're cutting, depending on the size of that block, we'll have to make more or less cuts. So with that, we'll have to do some looping in our macro. So that's really what gives macro most of its power, is the ability to do looping and also evaluate parameters and then do something based on the result of that evaluation. So if statements and while statements. If is logic to branch, and while is logic to keep looping while something is true. So both of those we're going to need for our facing program. So let's just start by creating a basic G-code program. This is going to be, I guess we should mention this as well. I'm going to try and program this for Haas. Haas's macro is slightly different than Fanuc's. There's a few things that don't work in Haas versus do in Fanuc and vice versa. So we'll have to try and address those as we go here as well. So with any program, we need a program number. Let's go 2020. Should be giving it a name. Always comment on your G code when you're making it so you know what you're doing. So we'll call this a facing macro. At the very top, this is personal preference safety code stuff. So maybe I'll just leave that blank and kind of, if you're going to use this program, insert whatever safety codes you want. Safety codes are stuff like G20, making sure that you're in inch mode, G17, setting your planes to XY, canceling any, G80s, canceling any active can cycles, or G49. Whatever you want to put in there safety codes, go ahead and stick those in. Simco is pretty flexible about not worrying too much about that stuff, so we'll leave it out. Another thing I would suggest at the top is you make notes about how this program is going to work. Where is datum, not only for X and Y, but also for Z. So I'm going to go with, when we do this first program, let's maybe hop over here and figure out what it is we're going to do. So let's get a color here. So basically, to start, I'm going to have a block that's 6 by 4. Okay, I'm going to write this blank program that we're going to base this off of for our macro programming. Okay, and I said I want to place datum basically up here. Okay, because 6 by 4 block, datum's top left-hand corner, and we're going to use a cutter. We'll say this will be a 2-inch cutter, and we'll face this block here with this cutter to start. Okay, so let's hop back over to Simco and datum top left and Z0 at top. Okay, so there we got some notes there, so we know how this thing is supposed to work. Let's carry on to what would happen next. Typically, what would happen next is once we get into our macro, we're going to probably set some values up here. Whoops, let me get that back over. So these will be where I'm going to store some variables. We'll come back to this in a little bit. And now we're going to get into the actual program. So let's just make note of what we're doing. I'm facing 6 by 4 block, and this is just to start. Okay, so we're going to come back. We'll remove this comment because it'll be able to work for any size block that we choose. So to face this block, how would we do this in a normal G-code program? We would call up our tool, and again, make note of what this is. This is a 2-inch face mill to start. And then to get this going, G00, G90, G54. So rapid absolute positioning, work offset G54. And we would move to an XY coordinate that our cutter can plunge down on and not obviously hit into our material. So with this, we need to get a X position. Let's maybe go like this. So this being 0, how far back in X do we need to go to make sure that this does not plunge into this? We need to go at least the radius here, and then plus an extra amount in here. Okay, so radius is 1 inch, and an extra amount, let's be kind of cautious and call it half of an inch. Okay, so at X, we're going to start at minus 1.5. For Y, if we put again, we're not doing any cutter compensation here. We're all doing center of spindle programming. So if I program center of spindle at Y0, we're going to have 1 inch of cut. Now, do we want more than that? I think probably a little bit more would be fine. We could probably get away with 1.5 inches of cut. So what I'm going to do with that is I need to move the cutter down an additional ½ of an inch. So our Y value will go at minus ½ inch. Okay, that's my phone exploding. Let me just move that out of the way. And we'll come back into Simco. Okay, so I said X was minus 1.5. I said Y was minus 0.5. We're now in position. Next up, we need to call up a spindle speed, 1500 M3. We need to bring our tool down in Z now, so let's go G43H1. I like to stop above the part and turn my coolant on. It gives me a little intermediate breakpoint where I can kind of verify that work offset's been picked up correctly, tool length's been offset correctly, and you're not wrapping too close to the part. And then next up is where we would feed down to, lost my cursor, Z0. We can go at a faster feed rate because we're plunging in air at this point. And at this point, we would face across the part. Okay, so we're down to this position now. Now we need to face across the part. How far do we need to go? So the cutter needs to get over to here. That's kind of in a terrible position. Let's go down here. So how much beyond this 6-inch do we need to go? Let's use this same logic here, over here. So I'm going to go to X 7.5. So this is basically our 6 inches plus the radius of the cutter, and then plus an additional 1/2 inch of clearance. Okay, so now we need to move down for the next cut. And if we're taking 1.5 inch wide cuts to start with, we're going to move another 1.5 inch. So if we're at minus 0.5, that'll put us at -2. And then we need to zig back the other way now, which will go back to that same 1.5 inch. So just to show where we are on this block, so we move down to 2.0, and then we're feeding across back to this same position, and we'll have one more cut down and one more cut over, and that should finish our block. Okay, so this one's going to go Y minus 3.5, X 7.5, we're done. G00, Z 1 inch, sorry 1 inch, let's turn the coolant off. And then we would home the machine in Z and home the machine in Y. And then program end, and we're good. So yeah, we could have used G53 in here. Since we're using the Haas, it's just a habit of mine to use G28. And I don't think Haas really cares much about the percent symbols either, but again, old habit, I like to include them. So does this program actually work? So the beauty of Simco, we can hop into Backplot, click on our Backplot window, and there's our program. Okay, so it looks like it's doing what it's supposed to do. We can verify this. Like I said, Simco has solid verification, and we can define our block size here. So min X will be 0. This would be -4. Let's go -1. I'm going through this kind of quick because we got a lot of work to do, and I'm trying to get this all inside of a 1-hour window. So if I am moving too quick, don't worry. This will be recorded. You can step back and review it afterwards, and hopefully it makes more sense then. And let's go 0.1. So this will give us 100 thou above Z0, and we should be able to see this actually facing. 2-inch cutter, looks good, hit OK. Yeah, so Simco sometimes likes to do odd stuff, so let's try that again. -4, -1, 6, probably won't like that. 6, 0, and 0.1. Let's try locking the stock this time. 2-inch, that looks better. Let's click play. Okay, so that's, yep, that's what we programmed. So 6x4 block getting faced with a 2-inch end mill. Okay, so now we've got that basic program there. We can transition into making this a macro program that can face any size block. So step 1 is to make this a macro program that will face this block, and then put some logic into it that it can adapt to new sized blocks. So let's hop back over to Backplots. And the first thing that we're going to need to know about this is the size of our block, right? So let's go variable number 1 is 6 inches. Again, always comment about variables you're making, what they are, what you're doing with it. This is the size of the block in X. Next one should be straightforward. 4 inches, this is the size of block in Y. And then next up, things that affect this program is going to be the amount of material we want to cut with this cutter. So we're using a 2-inch cutter, so I'm going to say 1.5 inches is my step over with that cutter. So this is cutter step over. and this is a physical size in size. I don't know if that makes sense. Size. So basically, why I wrote this in size is because we could use a percentage calculation in here, which that gets more into optimizing this macro, which we can come back to if we have time. But for now, we're going to physically hard code in the step over we want this cutter to be taking, or the max step over that this cutter can take. A couple comments over here on the YouTube. What program is this? So the one I'm in right now is called Simco. And I will be hopping into this guy at some point as well, NCPlot. You can get them both on free trials. I'm pretty sure NCPlot has a 15-day or maybe 2 weeks, whatever, free trial to start. And I think Simco has a 30-day free trial so that you can download and try it out for 30 days for free. They are paid programs. You do have to pay for them if you want to own them and use them every day. I don't know of any free NC plotters that would support macro programming. So unfortunately, if you use it on a trial, if you can get a student version, I don't know if they offer student versions, but that's what I'm working with: Simco Edit and NCPlots. Okay, so yeah, to download it, just go to the websites. There'll be links to download free trials. What else we got going on here? Some comments over on Facebook. Yeah, but where else can you stream it? Yeah, so this is being streamed on Facebook, being streamed on YouTube, and being streamed on Twitch. So hopefully one of those works for you. Probably the easiest place would be YouTube, but yeah. So let's keep on keeping on here. So we talked about our cutter step over. We also need to use our cutter size, because the cutter size we used on the approach points and the overlap. So we'll need that information as well. So this is cutter size. Okay, so we're storing these values in variables numbers 1, 2, 3, and 4. One thing about variables, these are what we refer to as local variables. Basically what that means is once we populate these variables, as soon as we hit this M30, all these numbers will be removed from those variables. So they're not permanent, they're only active when this program is actually running. So that's different than variables like number 500 where all your probe information is stored. That stuff is always there even if you exit a program, even if you power the machine down, those variables are always populated with those values. So one thing to be careful of is that if you are putting in temporary program values that you're working with just in app program, that you don't go and overwrite some permanent value, because that can cause havoc with things that need that value to be correct. So the safest variables to use are these low ones, number 1 to number 33, I think it is. Okay, so let's keep on going here. So with this information here, we can start to plug in values in here. So we can get an X starting position, because we know where the datum is, we know the size of the block, and we know the size of our cutter. So from this, we could make this a variable. Not just a variable, but we can make it a statement that will adjust depending on the size of the cutter that we take. So basically what we've done with this is we've taken the size of our cutter, which is number 4. So let's put that in, number 4. And we took half of it, right? Let's go back to this sheet over here. We took the radius of the cutter. So the radius is obviously half the diameter, so divide it by 2. And then for this example, if it's going to let me hop back over here, come on now. We just gave it a hard value for clearance. We gave it a 1/2 inch of clearance. So let's just stick with that logic for now. Here we go. Come on, let me back. The computer is not happy right now. Let's just give it a second to think. Okay, so there we go. So yeah, we're gonna just hard code this in of 1/2 of an inch. But keep in mind we want to go back further away from this, so we'll go minus 0.5, and let's close that down. Okay, so there's one thing we've done. We talked about this, I believe, in the first lesson, encasing math formulas inside of square brackets. So it evaluates this whole statement, and we'll populate that as an x value. And currently, right now, what this will evaluate as is 1 minus 0.5 will result in a value of positive 0.5, which is not what we're after. So let's go plus 0.5. What we can do here is just make this whole thing negative. Now, is this ideal? Does this work for everything? Do we always want a 1/2 inch of clearance? Do we maybe want to use a percentage of the cutter for clearance? It's probably a better idea. Maybe instead of taking the radius of the cutter and adding a 1/2 inch, maybe we just always say we want 75% of the cutter's diameter to be that far away from the edge of the part. So I think that's going to work a little bit better in the long run. So let's do 4 times 0.75. So there's 3/4 or 75% of this cutter's diameter. That's where we're going to position the cutter to start this cut. So next up, for Y, we talked about max cutter step over. So what we can do here, this is we've got to start doing some figuring here at this point. So even though we could just say, yeah, we know that we want to have 1.5 inches of step over, what's going to happen if we make this first cut 1.5 inches? If we make this first cut across here at 1.5 inches and the next cut at 1.5 inches, that means we've cut 3 inches of material, and our last cut is only going to cut 1 inch. So we're not splitting the workload evenly up amongst the 3 cuts. So if you want your cutter to last longer, you're going to apply a constant load to it throughout your programming. So we need to figure out basically how many cuts we need to take across this part based on this value here. So what we would do is we would take the amount of stock we want to cut, 4 inches, and divide that by the maximum step over. So divided by 1.5 inches. So to take 3 equal, or to evenly cut 1.5 inches, we have to take 2.6 cuts. We can't take 2.6 cuts. We can only do whole cuts. We can either do 2 cuts or we can do 3 cuts. We can't do 2.6 cuts. So we would have to round this number up. So we need to take 3 cuts to not exceed the maximum size. If we took 2 cuts, we would exceed this value in here. Okay, so we're assuming that the programmer has defined a maximum cutter value for a reason, not just for the heck of it, but because they don't want to exceed that value. So even if you calculate this out and you needed 2.01 cuts, if you made it 2 cuts, you're going to be exceeding this value and not respecting the programmer's wishes. So we always need to round that value up. So in our calculations to figure out our step over, we need to adjust it based on what we want to cut. So we're saying we need to do 3 cuts across this part. Okay, so how much is that step over now? So 4 inches to cut, divided by 3 cuts. Our new step over is basically going to be 1 inch, 333 thou. Okay, so we're going to take 3 cuts of 1 inch, 333 thou. And that's going to be our new adjusted step over. Okay, so we need to do some calculations down in here to figure out these values we just talked about. Okay, so what did we talk about? Let's change this color over here. We said we need to take our stock size divided by our max, our maximum step over, and this is going to give us a number of cuts. Okay, so after this number of cuts, we need to then round this up to a whole number. Once we get this new whole number, so we're going to have a new number of cuts. We need to then, take our stock size divided by the new number of cuts to come up with a new step over. Okay. So let's go back to our page over. Oops. Back into Simco. Again, let's figure this out. Let's figure out our step over size. Calculate the number of cuts. I'm going to store this in variable number 20. And this is going to be our number of cuts. Okay, this is pretty straightforward. We just said we're going to take, let's maybe make note of this in Y. Before we go too much further, okay, I think we're good as far as comments go. Number of cuts in Y. So we're taking our stock size, which is number 2, and dividing that by our maximum cutter step over, which is number 3. And we'll, again, encase this in brackets just to make sure that number 20 gets set to this whole evaluated equation, not just gets set to number 2. Now, as mentioned, when we do this math, 4 divided by 1.5 is going to be 2.6666, whatever. We need to round that to a whole number. So with macros, there's functions that can help you out with this. There's a function called round. But round works exactly like you think it would. Any decimal 5 and above, it will round up. Any decimal 4 and below, it rounds down. And we just talked about we can't round down our cuts because we'll then exceed the max step over. So we always need to round up. And this is also why I mentioned this at the beginning of the lesson here when we talked about Haas versus FNUC. FNUC has a nice, easy program word called FUP, F-U-P, FUP, which will, no matter the decimal of a number, unless it's 0, it will round it up. So it's fixing that number up. We do not have the access to FUP in Haas. Haas has a function called fix, as does FNUC. And fix, what it does, it just removes all decimals of a number. So we can use this function, fix, to determine if we, in fact, have a number with a decimal or a number that's a real number. A real number as in there's no extra numbers after the decimal. So we're going to use fix to try and evaluate if this has divided wholly. So you can see if we had a size in Y of 4 inches and we had a 2-inch step over, 4 divided by 2 would be 2, and you would not want to round that number up. Okay, so we need to make sure that if it is a whole number, we don't round it up. But if it is an integer or a real number, we do need to round it up. So here's what this is going to look like. This is where we can use an if statement. So with if statements, basically, if whatever I put in this brackets is true, it will then do what I put over here. Okay, so we're going to say if I fix, and we'll go number 20. So the result of this, if I take away all the decimals off of it, if that does not equal number 20, whoops, not 40, number 20, then what I'm going to do is I'm going to take number 20 equals, and then I will force this number 20, whoops, up one number. So basically I've tested the fact here. If I take all the decimals off of number 20, so in our example, if I take 2.6, strip off the 0.6, I'll have 2. If it does not equal 2, then I'm going to equal, or I'm going to increase it by 1 to make it 3. So we might need to draw this out. So scenario number 1 is I've got 2.66. Number 2, I've got 2.00. If I fix this, I'll get 2. If I fix this, I'll get 2. Okay, so if I compare this fixed number to the original number, are they equal or are they not equal? So one will be equals, one will be not equals. So whenever I get one that's they are not the same, that's when I force the increase in the number. Okay, so that's our workaround for Haas. With Fanuc, all we would write in here would be number 20 equals FUP FUP 20, and then we'll be done with it. Okay, so some bonuses in Haas and some bonuses in Fanuc. Okay, so now that we knew this, we have this new number of cuts. We said we need to calculate this new step over value. So now we need to take, let's stick this into number 21. Let's maybe make note of what we did up here first before I get too far away and forget what we did. This is round cuts. And this time is going to be calculating the new step over based on the rounded cuts. Okay, so how are we doing this? Number 21 is going to be our size of our block. Number 2 divided by our new number of cuts, which is number 20. So now we know how much we can cut with this cutter given this max size, given the size of the block. So this number should evaluate to 1.33 repeating. So now that we know how much we can cut with this, now we can get back to finally talking about our Y value, our Y start position, and giving it a location based on how much material we said that this cutter can actually cut. So let's make another variable here. Let's go with number 22. And this is going to be our Y position. Okay, so how are we going to figure out the Y position? So keeping in mind that we are not doing cutter compensation, so we're programming center of cutter. And 0, 0 is here. So with this 2-inch cutter, if I place if I place Y0, if I place the center of the cutter on Y0, I'll be cutting the radius of the cutter. Okay, I'm going to be cutting 1 inch deep. If I want to cut more, I need to move down more negative, right? So in this case, I would need to move down 0.33. Now we said our step over was 1.33. So to get this value here from these two values here, I can take the cutter radius and subtract our new step over. And that will be our Y position. So let's go ahead and do that. So I said we're going to take our cutter radius, right? So for cutter radius, we're going to take our cutter diameter, which is number 4, divided by 2. And then we're going to subtract our new step over, which is number 21. Okay, so this is going to be our Y position. With that, I can now plug this into Y. Okay, so let's give this a shot. Number 22. Did that work out? I don't know. Let's just start to play this up here. Here's our cutter cutting. There's the Y coordinate, minus 0.333. That's coming from this Y value right here. So this, in fact, has evaluated correctly. So let's maybe just make note of a few things at this point. I said I was going to hop into NCPlot. Let's do that now because I think we can see the difference between these two softwares. So I'm going to copy all this. Let's go all copy. I'm going to hop over to NCPlot. I'm going to paste this in here. This guy over here. Notice when I start to play through, you're getting variables being listed and the evaluated value for that. So this is extremely useful, especially when you get into calculations like this and you're not sure if something's working correctly or you're not seeing the correct output in your screen. You could come over and actually look at what those variables are being calculated as. So here we're seeing number 20 is 3. So that's where we talked about our number of cuts. So that's getting calculated correctly. Number 21 was our new step over value. So there it is at 1.33. And then obviously our Y position, again, minus 0.3, which is what we expected. So far we're on track. So I didn't really need to use this tool. But NCPlot, this guy over here is super, super valuable. I hope that one day Simco includes something like this in their software, but for now it's not there, so this is how we roll. Okay, so where are we at? We are 40 minutes in, and I think at least we have the hard stuff out of the way. Let me just get an idea here where we're sitting at with comments. Looks like nothing much happening. Okay, we'll just keep on going. So probably a good time, I guess. Now this is a good time to maybe let the brain rest for a second in this macro, and we can talk about. Just want to check my phone. Let me see. I don't have any messages about things that aren't happening or working. Okay, nothing terrible. The big announcement. The big announcement. Let me see what I can bring up here for the big announcement. Where was it? Just give me a second here. So basically the big announcement, while I'm looking to bring this document up, maybe I'll just go ahead and say it. Mastercam 2021 is just around the bend. It's supposed to be out soon, as in, I think they plan for a June 1st release. So, basically, what our little announcement is, let me bring this over. Our 2021 content is starting to be populated onto the website today, this afternoon, to be specific. If you already subscribed to us, then you should see some courses start to pop up in Mastercam 2021. So what's ready right now in 2021? Mill 2D is there. Mill 3D is there. Lathe is on the way. Wire is there. Solids are there. Mill tips are all there. There's new mill tips this year. We're bringing back some old courses that we hadn't updated previously. So there's new updated content that wasn't there last year. A lot of videos have been completely redone. A lot of lessons have been completely redone. So there's a lot of new content, even versus last year, that's going to be available this afternoon. So lots of videos there. If you're interested, go check it out. If you're already subscribed, go look this afternoon. You should see an email come out. And if not, you should at least see, when you go to my courses, click that pull down. You should see 2021 in there. Click on that, and you're going to see courses available to you now. And there will be more coming shortly. So we're still updating. We've still got lathe 4 axis and 5 axis to go, but they won't be too far away. So Mastercam 2021 content is now out. Mastercam 2021, the software itself, is supposed to be, to my knowledge, out June 1st. And typically the HLE version lags behind by about a month. So even though you couldn't really use Mastercam 2021 unless you are a subscriber to Mastercam or on active maintenance, you couldn't load the software, but at least you can look at the videos, see the differences, see what's new, see all the fun stuff, and look at the new content, look at the new stuff we've got going on there. So that was the big announcement as far as what we've got going on, new Mastercam stuff. A little bit later as well, kind of like we did in the last stream, we'll see if we can do a bit of a giveaway as well to kind of give back to those that have made it through the entire stream, depending on how many of you make it through. We're going to leave a poll open this time for a couple days. Sorry, I'm just trying to check this out on my phone to see how make this work. Basically, last time we had you guys go to a blog post and fill out a link. It was just the easiest thing I could think of to come up with for entering in without putting your email address into a chat box. So what we'll do is we're going to open a page on the website. Just go there, leave your email, and we'll do a draw in a couple of days. So that way, everyone can get in and enter it, and everyone, especially those that don't watch live, can get into it as well. So more on that post or that place and where to enter in a little bit. Okay, so 142. Let's see if we can get this program finished off here in the next 20 minutes or so. It might take a little bit more, but I'll do my best to get through this. So we got our Y position figured out. Now what? Now what? So this stuff in here is basically going to remain the same no matter what. Okay, or at least for the program we're doing. Okay, so all this stuff right to here is going to be the same. We're going to go to this height offset, this first position, and Z, and we're going to feed down to Z0. I guess we need to put a new cutting feed rate in here, unless you want to cut at 100 inches per minute, but probably not. And basically this stuff in here is where we need to put some logic to generate the cuts needed based on the size of the block. Okay, so this ending is going to stay the same. This is all staying the same now. We just need to adjust our steps here so it can determine how many steps it needs to make. And then is it going left or is it going right? So how can we do that? This is where we're going to get into a loop. We're going to get into a while loop. So we're going to say while something is true, do this. And as you would expect, while looks just like that. You just type in while, and basically square brackets. While this thing here is true, do something, and it'll be do one. Okay, so what does do one mean? It means you keep doing this stuff, and you loop back when you see the end one. Okay, so do one is going to. Sorry, I think I need to take the 0 out. I'm not sure if it matters or not, but basically it'll keep doing whatever's in here. It'll come down. Once it sees end one, it'll loop back up to here, reevaluate. If this is still true, it'll execute through this again. Okay, so that's great. What would happen right now is, since nothing is changing, say if I do, if I did this, while number one has a value in it, this will evaluate as true, and this will loop basically forever, since it would never change. It would always evaluate true, and it's always going to evaluate. So we need to look at something here, a value that's going to change. So what we got here is we know how many cuts we need to take, right? We know we need to make, we calculated some cuts up here. Sorry, right there, number 20, our rounded cuts. So we'll say, well, number 20, and let's go is greater than 0, do 1. Okay, so we know we need to go 1, 2, 3 cuts, and we need a way to make number 20 change after we've made a cut. So down here, we're going to say each one of these loops is going to be 1 cut. I'll say number 20 equals number 20 minus 1. Okay, so now when we loop through this, so our first time in, number 20 would be 3. We'd make a cut. Down here, number 20 would now become number 2. We would loop back up. 2 is still greater than 0. It would cut again, reduce by 1, same thing until we get down to 0. And whenever number 20 equals 0, it will then step out of this while loop. Okay, so that's how the while loop is going to work. So this is going to work for our Y positioning. Okay, so it's going to, basically we're going to get 3 cuts. Our next problem is we have 2 different types of cut. We've got a cut going in the X positive direction, and we're going to have a cut going in the X negative direction. So we got one going this way, one going this way. And that will even change. So this first cut is going this way, which we'll say is the positive direction. And we're going to have a cut going this way, which is going to be the negative direction. This here is going to be cut number 1. This here is going to be cut number 2. Okay, this one here is going again back in the positive direction. This is cut number 3. If we had more material to take, you can see this cut would be number 4, and it would be negative. So you're seeing a bit of a pattern here, right? So number 2, number 4, number 1, number 3. So basically our odd number of passes, or odd cuts, are going to be the positive direction, and our even number of cuts are going to be going in the negative direction. So we can do if statements again. We can evaluate something and look for a result, and based on that result, we can then do something specific. So we can test for, is the cut the first cut? Is the cut the second cut? So is it even or is it odd? But we need a way to keep track of that. We don't have a way to keep track of that right now. I don't know if this is the first cut, second cut, or 15th cut. So we're going to do another variable up here, number 23. And I'm going to use this as a pass counter. Okay, this is going to be used to count our passes. Is it number 1, number 2, number 3, number 4, whatever. Okay, and let's make that 1 to start, because once we hop into this, it is going to be our first cut. So pass counter equals 1. Whoops. There we go. Now we can put some logic into this. So how can we test if a number is even or if a number is odd? Okay, so easiest way to think about this, if you take an even number and divide it by 2, it will divide into a whole number, right? If you take 10 divided by 2, it's 5. If you take 100 divided by 2, it's 50. If you take 2 divided by 2, it's 1. If you take 1 and divide it by 2, it's 0.5. So you get a number, you get a decimal. Any even number will be a whole. Any odd number, it's basically going to be a decimal. So if we divide the number, our pass counter, by 2, we can tell if this number is an even or an odd number. Okay, so let's go with if number 23, which is our pass counter, divided by 2, if it equals, and we'll go with, we can use our fix again, fix, number 23 divided by 2. So basically, if we take a number divided by 2, and for example, 2 divided by 2 is 1, and is that equal to 2 divided by 1, which is 1, and then removing the decimal from it? Are those two things equal? If they are, then we have an even number. Okay, so basically if we have an even number, I'm telling it to go to 2. 2 is basically a line number, N2. Okay, now if this results in false, it won't see this go to 2, and it's just going to go down to the next line. And I'll call this N1 just for clarity. So at N1, this will be an odd number cut. And N2, this would be an even number cut. So when this statement gets evaluated, it hops in here, is it even or odd? If it is even, it jumps down to line number 2. That's what go to 2 does, sends it to line number 2. If this evaluates as false, it goes right into this next line and starts evaluating the G code from here. Now, what you might see happening is what could happen. If I see false, I'll hop onto this cut, it's going to then run through the even cut as well, which we don't want to do. So down here, once we've done our logic for an odd cut, I need to skip over this N2 logic. So it doesn't get executed. So basically, N1, do whatever you got to do here for N1. Skip down to line number 3, and then we'll end the loop. Here, it branches out to number 2, completes that logic, and then it would just run the ending program. Okay, so on an odd number cut, we're going in the positive direction. So odd number cut, we need to end up at X, and we're going to go with our stock size in X, which is number 6. And then we need to go past the cutter, and we can use this same amount that we used here, number 4 times 3/4. Okay, so anytime we do an x positive move, we're going to go to 6 plus 4, which is 2 inches, times 3/4. 3/4 of 2 inches is 1.5 inches. Plus 6, we should end up at 7.5. And there you can see 7.5 coming up in that position there. Okay, so what happens when we have cut all the way across, and we're doing a negative or an even number cut? We want to end up back at this position here, which is the same as this value right there. We want to end up back there. Copy, paste. Okay, so there's the logic for our even cut. So if it's an odd cut, we go to positive 7.5. It's an even cut, we go to x negative 1.5 in this situation. Okay, so once all that's done, we've hopped in here with a y cut, or our first loop for the y was number 1. We cut across an x. What we need to do here, after we've cut across an x, is we need to update our y position and make that move so that when we head back up to our loop again, we make that even or odd cut based on this new y position. So logic for this, so N3, let's call this our y move. And what can we do here with our y move? So we know where we're currently at in y. We are currently at number 22. Okay, so number 22. And we need to move down by the amount of our step over. Okay, so whatever our current step over value is, we need to move down that much more. So let's take number 22 and make it number 22 minus, because we need to move down more, our step over is, new calculated step over was based on number 21. Okay, I think that's good. So this will be, this is a new y position based on step over. Okay, so now that we've determined where that position is, we actually need to make that move now. So let's do that. Y number 22. Okay, so we've got our y number 22, which should be, in our situation, negative 0.33 plus, well, subtract 1.33, which should give us minus 1.66, which I'm seeing over here. We're seeing not quite correct stuff going on yet. That's because we have some more logic to input in here before we finish this loop off. Okay, so we've either done an odd cut or an even cut. Whatever it is, we made a cut. We need to update our pass counter. So let's update that guy right now. So number 23 will equal number 23 plus 1. So whatever cut we were at, we just made a cut and we're now looping. Okay, so let's maybe copy all this stuff. I don't think it's looking quite right yet. We've got that code in there that's making things go all over. Let's get rid of this stuff since we're not using it anymore. And here we are in our loop. Let me just check the comments. I think we're all good. I'm not seeing much happening. Okay, where are we at? 1 hour in. All right. So currently right now, our loop is not working good. And I think what the best way to do, we should be seeing loops back and forth. Let me just copy all this stuff. And this is where I think using this stuff works much better. Okay. So it looks like numbers are getting evaluated correctly in here. Oh, I can see a mistake right there. Maybe that's not liking stuff. Very important you type a do as a do and not as a D0. And I'm missing a square bracket there. So this is where macros can get to be a little frustrating. There we go. Okay. And I also find that NCPlot is better at generating errors like this. Like you saw that Simco didn't care that I had a D01 instead of a D01. And Simco didn't care about this missing bracket either. So let's copy that. Let's head back over to Simco. And we'll paste in the stuff that I just edited. And let's see what we get over here now. Okay. So we had the, I saw the position show up there for Ys, but we didn't get our cut moving the opposite way. So basically that's telling me that this is not evaluating correctly in here. And this type of formatting as well can be dependent Fanuc versus Haas as well. I think Haas, when you do a go to, it doesn't like a then. But that's not updating our problem quite yet. We got our do in here. Let's just try this here. Let's copy from the other one. There we go. There we go. So now it's fixed up. Brackets, very important. Make sure you count the opens and closes and that they do in fact match. Okay, so our loop is working now. Let's have a look at it. We're on the home stretch here. So that's working. Let's just have a look at the positions as we're running. That position is not correct. That's coming from here. Okay, so our X is only moved to 1.5. That's right in here. So let's include some brackets with this, because we should be getting number 6. That's our problem right there. We don't have a number 6. We have a number 1. Right? Yeah. Yeah. That should make more sense now. Let's try again. Okay, now we're getting somewhere. Simple little typos like that will just ruin your day when you're macro programming. Okay, so yeah, even if you're thinking 6 inches, put in the correct variable that holds the 6-inch number. Okay, so I think what we're seeing now is good, except for that move right there. We don't need this, so this last move here has cut the block. But since our Y movement is happening down here at the bottom or the end of our loop, we're going to get this Y output at the end. So what we can do to fix that, even though we're calling our Y position up here to start, we can still call a Y position in here, and if they're the same, obviously it's not going to move. So what I'm going to do here is just move this Y coordinate up to the top of the loop, and it gets rid of that Y position happening at the end. Let's just clean this up a little bit. Okay. So we're almost there. Our macro works for our 6x4 block with our 2-inch cutter. Does it work if we update our block size? So moment of truth now. If all you're going to do is face 6-inch by 4-inch blocks, this program was probably a waste of time. If you're doing more blocks, then this needs to work when you adjust these sizes. Let's say we're doing a 16-inch block in X. So there you can see our program is automatically updated. Let's say the block is 14 inches in Y. Let's just make it 14. Code updates automatically. Keeps the consistent step over. But is it just looking like it's working, or is it actually working? So let's use the power of Simco again here. And I should make point of this right now. Save your files. Save your files. I should have saved a long time ago. Simco and anything else, not just Simco. Any software always crashes at the worst possible time. And it's usually when you've got 45 minutes worth of work in there that you have not saved. So always save. So let's see if we can set up a 16 by 4 block. And cut this with our 2-inch cutter. Fantastic. I think we are in business. Our facing macro will now work for any size block we give it. Any size block, any size cutter as well. So let's say we reduce our cutter size. Let's go down to a 1/4-inch cutter. So right now this is not good because we also have to update our step over size. Let's say we wanted to do 1/8 of an inch. You can see all the code that gets generated there. So that's why I mentioned earlier on as well, we could, instead of having to update our step over size, if we did this as a percentage, we could do a step over calculation based on a percentage instead of keying in an actual step over size. But I think for now it works just fine. There's definitely some improvements we can make to this. If I run a 1/4-inch cutter versus a 2-inch cutter, I probably want to update speeds and feeds, which I don't think we even have a feed on our first movement, so we should be putting an F in there. So we could put in some more variables up here for calculations on RPM. We could say an RPM calc here. We could do a feed calc here. Make sure that the program doesn't read this. Okay, and that's going to make our program better and more adaptable to different types of cutters that get chosen. We could also put in an SFM if we're cutting aluminum or are we cutting steel. We can use that SFM based on our cutter size and calculate specific RPMs for not only the cutter, but the material that we're cutting. What else could we do in here? As mentioned, we can do the percentages here. And then taking it even further would be adding in depth cuts. So if you wanted to add in depth cuts, you're going to need to loop not only this, but you're going to have to loop around all of this. So you're going to loop this, and then you're going to loop a depth cut. So you'll set a new depth cut, and then re-loop this whole program. Next depth cut, re-loop the whole program. So definitely possible. I think as far as scope goes today, I think we are out of time. We're over an hour so far. I'm surprised we got through this. I did go kind of quick, but again, I wanted to get this in a reasonable amount of time, and I think an hour is reasonable. But there's definitely more we could do to this, and I think this is a good part 3 into our macro videos. Someone has put a comment up here, and how can we learn macro pre-program? There is some books out there. A book I would recommend is... Let me just see if I can remember the title. Here it is. So as far as learning macros, we don't have a macro course. It's something we've thought about doing. It's a maybe thing. Mastercam is kind of our main focus in getting Mastercam courses updated and new stuff in Mastercam all the time. This has been a little pet project. We've been putting out blog videos every once in a while. But this book is the best one I've seen as far as learning macro programming. CNC Programming Using Fanuc Custom Macro B by S.K. Sinha. He's also very active on some of the forums. Practical Machinist, I believe he visits quite often. So yeah, definitely a good book. There's another one here. I've not looked at this one by Peter Smid. I've heard it's good. I've not read it, so I can't give honest feedback on it. But this one is definitely fantastic. There's some other guys out there as well that have some macro stuff. I think Mike Lynch has some macro programming stuff as well. So you could check out his stuff. But that's the book that I've looked at, and that's the book that I learned most of the stuff that I've learned from. But as far as anything, just reading about it is not enough. You need to actually do it. Get into Simco edit and program a macro. Stay late after work and program your codes on the control. So this, I guess one more point we should make here. This works in Simco. This works in NCPlot. You may find when you go to your controller, you get little bugs that happen out there that you didn't see in your Simco edit. I was going to try and pop one up on the controller here, but I don't know if we've got time. My controller seems to have powered off as well. And by the time it boots back up, yeah, by the time it'll take 5 minutes to boot back up. I was going to try and run this on the Haas simulator, but yeah, maybe we'll skip over that. Just not enough time today. So I think that's about it as far as today's stream goes. We covered lots. We talked about calculating things in macro Bs. We talked about loops. We talked about if statements. We went over just this process, which I think for any macro program you do is a good process. Write down what it is you're trying to do. This is a flow chart for me. I know it's not a flow chart for most, but when I'm going through a program, if I start scribbling down what it is I'm trying to do, you can start to see patterns and loops and things that you need to cover in your macros. So very helpful to do some sketching and some thoughts and getting them down on paper and just seeing them that way. So I think other than that, I think we're going to wrap up. I'm not seeing any comments or questions, so I think we'll just leave it at that. As mentioned, a draw. We did talk about a draw. And what's the draw going to be for? We usually, last time we did a couple t-shirts, so we could do the same sort of thing, a couple t-shirts. But seeing as Mastercam 2021 has just come out, then maybe something from 2021 is an idea. Hold on, trying to get my phone open here to see a message. Okay, so there's the answer. Basically, when you enter into this draw, if you win, you'll get an email from us, and you'll be given the choice of what you want. Okay. So how do they enter? How do you enter this draw? Maybe Megan can leave a comment in the chats, a link. We'll just wait until I see a link show up, maybe. All right. Well, hopefully there's a link coming out here soon. If not, I'll post a link on a Facebook post. Okay. Yeah, I'm not seeing anything back about a link, so we're gonna just we'll wrap her up. Again, questions, comments, feedback. Be sure to leave comments on our videos. I'm gonna be putting out polls again. Asking what you guys want to see. Make sure you reply to those. That's why we did Fanook Macro B today. That's what kind of got chosen in the last poll. I think it was about 35% voted for Macro B versus, I think second place was a 3D toolpath was about 30%. I would like to do an easy part in Mastercam, or a basic part is a better way to term it, I guess. So that might be the next one regardless. But yeah, there I'm seeing a link there in the chat now. So click on that form. I think all you gotta do is put in your email address. Obviously, we need to be able to contact you if you win, and email is the easiest way. And this prevents you from having to put an email into a chat box. So click on that, put in your email. Everyone who enters, you'll be put in the draw, and you get to pick basically what you want. I would pick one of these shirts though; they're pretty cool. Okay, so with that, we're gonna wrap it up, and we'll see you guys in either a week or maybe two for the next stream. All right. Thanks for sticking around. We'll see you guys next time.